Hi, thank you for watching my talk. Today, I'm going to be telling you about an experiment I did during my PhD at Michigan State University that looked at how AB's past experience with predictability or unpredictability in the timing of rewards shaped her exploratory behavior. So much like any foraging animal, when honeybees are foraging, they face a number of challenges. For honeybees that forage in a landscape that looks like this with discrete patches of resources, they have to solve two primary challenges. First, figuring out where the resources are located. Second, figuring out when to show up to get those rewards. It's this latter one that I'm going to focus on in this talk. Now, this figuring out when to show up to get a reward is actually quite challenging for the honeybees because there's often a lot of variation in when those rewards are available. Now, this is often a predictable variation. So most flowers have a daily pattern in when they secrete their nectar. And from year to year, there's fairly consistent seasonal resource turnover as well. So these predictable sources of variation are ones that honeybees can learn, either through their own experience or through their evolutionary history. They've learned it, but not all variation is predictable. Things like the weather or competition from other foraging insects can also unpredictably change when rewards are available to honeybees. And so they can't learn this information. So when honeybees are foraging, they can use these predictable and unpredictable experiences to help guide their future behavior. Previous research has shown that a bee's recent reward history or uncertainty in the timing of rewards that she's just experienced can indeed influence when and how much she searches for rewards. However, most of these studies were conducted in laboratory assays, often using choice experiments. And so we don't really know much about how a bee's past experience can influence her search behavior for rewards in a free-flying scenario. We also don't know very much yet about how her experience influences her behavior in some situations. For example, when rewards vanish. Now this situation where rewards you were previously using just suddenly vanish is one that honeybees are likely to experience quite often because flower patches only last a few days before dying out. And then also humans might frequently mow down fields that honeybees are foraging on. And so in this study, I was really interested in looking at how a bee's experience with timing of rewards and how predictable or unpredictable that might be. How does that influence her exploratory behavior when rewards are no longer available and she has to search? Now, it's important to know that honeybees are really, really good at learning the timing of rewards. They can do so even with just one visit. So I hypothesized that when bees have experience with unpredictable changes in the timing of rewards, once they can't learn, that would lead the bees to be more exploratory in time. Now, to think about what exploration in time might look like, because that's kind of a weird concept, think about how you might wait for a bus in the summer when the roads are beautiful versus in the winter if you're in a northern state like Michigan, when there's snowy roads and it takes who knows how long to get anywhere. Now, in this latter condition, when the roads are terrible in the winter and you're trying to catch a bus, you're probably going to get to that bus stop pretty early. You're going to wait at that bus stop much longer past the time the bus was supposed to show up because it's really hard to judge how long will it take the bus to get there. You probably also look down the road more frequently to see if the bus is coming yet because you just don't know when to expect it. Similarly, bees that experience rewards that show up at random times, they might be expected or that we would predict that they would be less precise in when they look for those rewards. So they would look for them over a broader period of time. We'd also expect them to be more persistent. So going and looking for those rewards more often throughout the day. So to test these predictions, I did an experiment inside of a flight cage where I trained bees, two groups from the same colony, one group to a constant feeder and one group to a changing feeder. And that changing feeder changed either predictably or unpredictably. Once bees were trained to their feeder, they got 7 days of experience in their world. Now at the constant feeder, bees got low quality food all day, every day for those 7 days. While at the changing feeders, they got mostly low quality food all day, but for half an hour every day, they got a really, really good reward at that feeder. In the predictably changing condition, the time at which they got that high quality reward at the feeder was the exact same for every single day. In the unpredictably changing condition though, bees again got half an hour of good food, but the time at which that good food was available was pseudo-randomly varied from day to day, such that no time was ever repeated. Now on the 8th day, we removed all of the rewards from the feeders and replaced it with water. So we called this the water test day. We simply looked to see how many times did the bees show up to try to find that food, and when were they showing up to try to find it. Now, when we looked at their visitation, we found that bees who had experienced any change searched more persistently than those who had never experienced a change. So you can see on this graph, this green line, those are the bees at the changing feeder. There wasn't actually a difference between the predictable and the unpredictable changing feeder bees, but in each case, bees at the changing feeder made significantly more visits on average than those at the constant feeder on this water test day. So they were showing increased persistence that was not dependent on how predictable of a change they had experienced. When we looked at the pattern of visitation across the entire day, though, we did find some differences in when they focused their visitation. So this graph is really complicated looking, I know, but these shaded regions indicate the last time the bees had experienced that upgrade. So the time they had that good quality food on day 7 and the half hour before that. And we just chose the half hour before to include as well, because bees are often anticipatory when they're looking for rewards or when they're showing up to timed rewards. So we wanted to take that into account. So if you look at the solid black line here, those are the bees that were at the predictably changing feeder. Notice that their peak visitation is pretty much entirely within that last upgrade time. Compare that to the solid green line, who are the bees at the unpredictably changing feeder. Notice their peak visitation was primarily before that last upgrade time. So those bees in the unpredictable environment were showing decreased temporal precision. Interesting to note, though, that their visitation was still primarily focused in the afternoon, which was the last time of day they had received a reward. So it seems like they're probably using their last experience to kind of guide their behavior. But remember, honeybees only need one trip, one experience to learn when to show up for a reward. So they're clearly not only using that last experience, or they probably would have been a lot better and had more of their visitation during that last upgrade time. Now, the other thing to note in this graph is the pattern of visitation between the solid and the dotted lines of the same color. So those dotted lines are bees that were trained to a constant feeder. Notice that the black lines have a similar pattern to each other and the green lines have a similar pattern to each other. So that to us tells us that maybe there's something going on at the in-hive environment where those bees at the constant feeder were learning when to look for food, even though they had never experienced a change themselves. And on this day in particular, there were no rewards available, period. So that's really intriguing and might be worth following up on. So to conclude, we found that a bee's past experience with temporal unpredictability did indeed influence how she searched. It did seem to decrease the precision of her behavior, as you would expect if she's not able to learn when a reward should be available. And it also increased her persistence. But here, it didn't depend on the predictability of that reward. Any change at all was enough to make the bee more persistent. So to end, I would like to thank the people in the lab who helped me, as well as my funding sources, and thank you all for watching.